Here is an explanation for the answer to final exam question number 9 in this book, Electronics Demystified, 2nd edition. The final exam question number 9 is found on page 417. We're talking about two complex number admittances connected in parallel, or we should say two components that have complex admittances. Y stands for admittance of these values connected in parallel. G stands for conductance. That is the reciprocal of resistance. B stands for susceptance, which is in effect the reciprocal of reactance. Conductance involves components like wires, resistors, things that don't exhibit any inductance or capacitance. But susceptance involves pure inductance or pure capacitance. These are sort of like the inside-out versions of complex number impedances. This all may seem very esoteric and very complicated, but we do this, we speak about admittance, which is the ease with which an alternating current circuit will allow current to circulate and flow. We talk about admittance in order to facilitate discussing parallel connected components. If we work with impedance, that's easy to work with in series connected components, but very difficult with parallel connected components. So if we have a component that has an admittance of Y sub 1 equals G sub 1 plus J B sub 1, and another component with the admittance Y sub 2 equals G sub 2 plus J B sub 2, we connect them in parallel. We simply add the conductances, add the susceptances, and get the result that way. Remember that J is the positive square root of -1, the unit imaginary number. So we simply add admittances. When we connect them in parallel, the admittances simply add. So we get Y sub 1 plus Y sub 2 equals G sub 1 plus G sub 2 plus J times B sub 1 plus B sub 2. Like that. I added these extra parentheses here, even though they're not technically necessary, just in order to isolate the conductance part from the susceptance part. And of course, if you add these, you can factor the J out. That's what you get. That is the general formula. It's really quite straightforward when you think about it. You just add them. Remember that conductances in parallel add. And that's how you can easily calculate the value of a bunch of resistors in parallel, figure out the conductances and add them up. Well, the same thing happens with admittance, but it's a little more messy because of this J operator. But anyway, once all this chit-chat is said and done, the answer to final exam question number 9 in Electronics Demystified, 2nd edition, C as in Charlie.